Shanti, Shanti, Shanti.
I request our principal ma'am, Dr. K. Shanta Garu, to begin the webinar with her opening remarks.
Thank you, Deborah. St. Joseph's, a warm welcome to all the participants of the webinar, and a special thanks to the beloved resource person, Professor Kumar Garu. I thank you very much, sir, for accepting this invitation within a very short notice. Thank you very much. St. Joseph's Degree College is governed by St. Joseph's Educational Society. It has been serving with the motive to provide quality education to the students from all walks of life. The institution has started off with science, computer science, management, and commerce courses. Currently, the college offers 11 courses in 3 undergraduate programs. The college is self-financed and affiliated to Rayalaseema University, Kurnool. Presently, about 3,500 students are studying in the college, out of which girls are more than 50%. The college has experienced and well-qualified faculty team who always strive to give their best to impart quality education to the students. The college also has eminent PhD holders who stand as a pillar of strength to the academic activities. The college is surrounded by green environment and excellent infrastructure in 11 acres, which facilitates effective teaching and learning. The college believes in creating the future citizens of this country and thus emphasizes on values and ethics. Every day, the college begins with a prayer, followed by a student giving out a reading an article in the assembly. The institution has earned goodwill due to the long academic experience combined with service motive. The college takes pride to state that it does not collect any donation or capitation fees from the parents. The college is an NPTEL local chapter to facilitate the students getting various certificate courses which help them in improving their skills. The institution produces university ranks consistently with the effort of eminent faculty members who contribute their fullest for the betterment of the students. The values we impart along with the education has been a point of conviction for the parents. The college over the years has constantly registered growth in all aspects. The college aspires to grow further to serve to many more students by starting many more courses in future. I congratulate the Department of Biochemistry and Zoology for coming forward and conducting this webinar on the most important and useful topic to everyone. And I wish and pray for the successful completion of this webinar. Thank you. Over to you, Deborah.
Thank you, ma'am. I now request our Vice Principal, Dr. C.V. Satyanarayana Garu, to introduce about today's webinar.
A very good afternoon to you all. So I am Dr. C.V. Satyanarayana, Vice Principal of this college. So today, I think the topic that is selected is completely relevant to the current situation. So in last 15 months, we are facing a lot of problems with the health, may not be personally, but in a society where we are living because of this corona. And we all know that there are a lot of videos that were posted on our WhatsApp, on YouTube, on Facebook, on Insta, and many other social platforms about health benefits through natural products. So natural products are something which are produced by plants and microorganisms which are living with us on the planet Earth. And these are the products that are like alkaloids that have medical importance and therefore used in the treatment of various diseases without any side effects or with minimum side effects. This is the speciality of the natural products, because they are what you call it as grown by microorganisms or plants which are natural. So definitely they don't have any side effects on a human being who is also natural. And natural products are powerful immune boosters and protect the human from various bacterial and viral diseases. So that's what the speciality of natural products is, because they themselves fight with a lot of bacteria, virus and all to grow on earth. So indirectly or directly, they also help us in boosting our immune system. So, and we have seen a lot of other advertisements like Chavanprash and many more things that are what you call it as marketed or branded by a lot of heroes and cricketers and so on. But today we got a chance of listening about the natural products and health benefit through, I can say, like a specialist, a scientist who can really give us real insights of what natural products are and how actually it works on us and how it benefits are in improving our health. So thank you for giving me an opportunity, and once again congratulations Department of Zoology and Biochemistry for conducting this such a nice program, which is the need of the hour, and I really congratulate them once again and wish them all the best. Thank you. Thank you very much.
Thank you, sir. What you said is very much true. Thank you for your encouraging words. And now I invite Dr. C. Srinivas Rao Garu, the HOD of Biochemistry and Zoology departments, to introduce the guest of today's webinar. Over to you, sir. Sir, please unmute.
Yes, thank you, Deborah. Thank you very much. Deborah, am I audible?
Yes, sir.
Yes, thank you. Respected principal ma'am, vice principal, and faculty members of different colleges, and my dear students, good evening to all. I'm very much excited and happy to introduce my dear friend and resource person for today's webinar, Professor Vadlapudi Kumar. Kumar is working as professor and chairman, Department of Studies in Biochemistry, Dean of Science and Technology, Davanagere University, Davanagere, Karnataka. Professor Kumar completed his master's degree in biochemistry from Sri Krishnadevaraya University, Anantapur in 1995. In the year 1995, he received Junior Research Fellowship from University Grants Commission, New Delhi, by clearing GATE examination. In the same year, he received JRF from CSIR New Delhi by clearing CSIR UGC NET examination. Professor Kumar did his MPhil on biochemical and plant tissue culture studies from the Department of Biochemistry, Sri Krishnadevaraya University in the year 1998. In the year 2004, Professor Kumar completed his doctoral degree from the Department of Biochemistry, Sri Krishnadevaraya University, Anantapur. During his doctoral studies, he worked on the biochemical and in vitro plantlet regeneration studies in anti-cancer plants. Professor Kumar got 23 years of teaching experience and 26 years of research experience. He published 65 research publications in various national and international journals. Kumar guided 16 students for PhD and 5 students for MPhil degrees. At present, 6 students have been working for PhD under his guidance. Professor Kumar completed several research projects worth of more than 1 crore sponsored by UGC, Department of Biotechnology and Department of Science and Technology, Government of India. His research areas of interest are plant tissue culture, medicinal biochemistry, and rDNA technology. He worked on antioxidant response in different plants, anti-diabetic and anti-cancer properties of phytochemical extracts from different plants. He also worked on molecular cloning and functional expression of glycosyl transferase genes. He is a life member of Society of Biological Chemists and Society of Free Radical Research in India. He is the convener for Society of Biological Chemists India, Davanagere branch since 2001. In today's webinar, Professor Kumar is going to speak about natural products and health benefits. Why would we have chosen this topic? Because medicinal plants, I mean the natural products like alkaloids, phenolics, and terpenoids have medicinal properties and used in the treatment of various diseases. These phytochemicals have antibacterial, antiviral, anti-diabetic, and anti-cancer properties. They also function as immune boosters and can stimulate the production of plasma cells as well as memory cells, which is a burning area during this current COVID-19 pandemic. Thank you very much, Kumar, for accepting our invitation. I hope and trust that all the participants will enjoy your talk, and definitely this webinar will be beneficial to all of us. Thank you very much. Deborah, over to you.
Thank you, sir. We are really very much honored to have such an eminent person amongst us in spite of all this pandemic condition. And now I cordially invite Professor Vadlapudi Kumar Garu to deliver his lecture. Over to you, sir.
Thank you very much, madam. Yeah. Good evening, everyone.
Sir, can you please unmute, sir? Unmute your microphone.
Am I audible now?
Yes, sir. Yes, sir.
Yeah.
Thank you, sir.
So, good evening, everyone. Honorable correspondent of St. Joseph College, the college which is known for its reputation, and Principal Dr. Shanta Madam, Vice Principal Dr. Satnarayana, Head of the Departments of Biochemistry and Zoology, Dr. Srinivas Rao, my good friend, and my colleagues who have been working in the departments of Biochemistry and as well as Zoology at St. Joseph College, Kurnool, and colleagues from other departments of the same college, their student participants, and participants from other parts. It's my pleasure to be online amidst you to share some of the views on natural products and their health benefits. And I would like to share the glimpses of our efforts as far as this particular field of science is concerned. To begin with, is it visible? Hello?
Yes, sir. It's
Yeah.
visible, sir.
Yeah, ma'am. Thank you. Yeah, natural products and health benefits. These natural products are nothing but the molecules or compounds which are produced by all life forms, right from bacterium, the model example E. coli to human being. All the life forms, they produce these molecules. Broadly categorized into primary metabolites and secondary metabolites. And these primary metabolites, what we call them as the metabolites which are required for the survivability and sustenance of the living organisms. They are generally known as biomolecules or biochemicals, of course. And these molecules, they are known as high volume and low value products. High volume, low value products. High volume in the sense, the living organisms, they produce these molecules in high quantity. But when you go for marketing these molecules, you will get it for low value, low price. There are many herbal products are available. Food industry, cosmetic industry, whatnot. Everywhere you can have a tag of herbal, a prefix. It has become common nowadays. And of course, these are low value products in the sense value wise they are very much essential, but price wise I am saying cost wise they are low value products. Right. The other class of natural products, they are secondary metabolites. They are the metabolites which are produced in low quantity by the living organisms, not all, some, of course, and they are high value products. High value products in the sense 1 milligram we could able to purchase for 1,100 rupees, excluding GST, one of the molecule. 1 milligram it is 1,100 rupees, and there are still molecules which are more costlier than this. So that is the value of the secondary metabolites. And these secondary metabolites, and primary metabolites, if you look at, this is the representation from a textbook, of course. These are the products of primary metabolism, like proteins, carbohydrates, lipids, as well as nucleic acids, of course. And secondary metabolites, they are broadly classified into alkaloids, phenolics, and terpenoids. There are some subclasses that are available. We can discuss about these things. Right. So this is a living cell. I have taken plant cell as an example. It doesn't mean that I have hesitation for animal cells. I love that. Right. So this is the plant cell where you can have the intracellular compartments, and largest volume in the plant cell, it is occupied by vacuole, and you can also have chloroplast, the marker for these plant cells, and mitochondria common in both animal and plant cells, and as well as endoplasmic reticulum, nucleus, and other Golgi apparatus and all other organelles that are there. And this living cell, if you look at, though it has many compartments, all these compartments and outer layer of this living cell, say if it is animal cell, it can be plasma membrane, and plant cell, over the plasma membrane we can have the cell wall also. Same is the case with fungal cells and bacterial cells, which are having plasma membrane, over that cell walls are present. All these membranes, then cell walls, intracellular compartments that are soluble environment, including cytoplasm, they all made up of with the presence of molecules, biomolecules. Since I'm a biochemist, I always love to say biochemicals, right? So they are made up of with biochemicals. And these biochemicals, broadly, as we have seen just now, about proteins, carbohydrates, lipids, and nucleic acids. And of these 4 classes of biochemicals, the proteins, lipids, and carbohydrates, they are considered as fuel molecules. Fuel molecules means which contribute for the cellular energy metabolism. Upon their degradation or catabolism, sorry, yeah. So they release energy, and of course, investing that energy or utilizing that energy, whatever the molecules that are required for the cell that can be built up. So the degradation or catabolism, building up a biosynthesis or anabolism, put together we call it as metabolism, of course, right? So these proteins, as we know that they are made up of with amino acids as their building blocks. Same is the case with lipids. They are made up of it, are built up with fatty acids, And carbohydrates, of course, we have monosaccharides, disaccharides, oligosaccharides, and polysaccharides. They are made up of with monosaccharides, of course, as building blocks. And nucleic acids, which are not considered as fuel molecules, they are made up of with nucleotide bases. And these nucleic acids are hereditary molecules, which are responsible for the hereditary characteristics from parental generation to progeny, right? So these high volume, low value products, primary metabolites, say if you want to go for protein rich foods, you can go for the pulses. And if it is carbohydrate rich foods, you can go for the say millets. And if you want to go for the say oils or lipids, you can go for oil seeds. So like this, you can have the different sources. Of course, all the pulses or millets, whatever it is, the grains, they do contain all the biochemicals, but one class or one particular group of these ones, they are rich in, say pulses, they are rich in proteins and little low in as far as carbohydrates and as well as lipids are concerned. Similarly, others, right? So this, apart from these primary metabolites, we do have secondary metabolites that are produced. There are certain microorganisms and marine organisms that too can produce the secondary metabolites. But these metabolites, they have become more popular and they have been isolated from plant sources in large quantities. In the sense, the research efforts are more as far as plant secondary metabolites are concerned compared to microorganisms and as well as marine organisms. Right. So the plants, as we know, they are sessile, they are immovable, in the sense they cannot move. But still they are able to protect themselves from all kinds of vulnerabilities they are getting exposed to, right from high temperature, low temperature, floods, and as well as drought conditions, winds, and including biotic factors like pathogens that can be virus, bacterium, bacterial pests, or fungal pests, even attack of insects and certain worms, right? From all this, the plants could be able to protect themselves by having their own defense, right? That defense is possible as far as plant per se is concerned by having these secondary metabolite molecules. These secondary metabolites, as the earlier I have made a mention that these are broadly classified into alkaloids, phenolics, and terpenoid molecules, right? So though we consider primary metabolites generally as high volume, low value products, but nowadays the biomaterials, they are occupying large market space as far as healthcare and as well as agriculture and other allied fields are concerned, including petroleum industry also. Right. So these are some of the examples as far as proteins are concerned, which are having high commercial value and their peptides degraded to products, nucleic acids, carbohydrates, and as well as lipids are concerned. These are biomolecules derived biomaterials and which are having very good value as far as contemporary market is concerned. Right. So this is the integration of chemistry, biology. Of course, the product is biochemistry, and where you can have these useful materials, biomaterials that are produced. And you can also have these materials that are used for this tissue engineering and all those things by getting integrated with medicine. So this is the integration of different branches of science and for the human welfare. Right. So this is the slide which I put to show that some vegetables which we commonly use like cucumber, tomatoes, and as well as chilies, and some common fruits which we use. And these are the sources of both primary metabolites and secondary metabolites. So in the slides subsequent, we can see what are these and how they are useful. Right. As far as the history of secondary metabolite research is concerned, it was started about 215 years ago. In 1806, the first secondary metabolite that is morphine was isolated from Principium somniferum. The plant name was then, now it is called as Papaver somniferum, by Frederick Wilhelm Sentner. The plant is commonly known as opium poppy. And this is secondary metabolites. Metabolites means the molecules that were isolated. And secondary metabolism means how these secondary metabolites are synthesized. That has been tracked by the people, and that is being, of course. And that research has begun. It was begun just 65 years ago. And how it was begun in the sense, the secondary metabolism research, radioactive isotopes. We know that carbon, the normal isotope or common isotope of carbon is C12, that is generally present in almost all the biomolecules, organic molecules. That includes biochemicals, of course. And that is generally considered as light isotope or normal isotope. And there is heavy isotope of this carbon, that is C14, which emits beta radiation. So if a molecule, how it is modified? Oh, almost all the participants, including students, they are familiar with glycolysis pathway. Nowadays it is in, I think, class 10 textbook, or at least intermediate level textbooks, biology textbooks, we can come across the glycolysis. So this is the pathway which is very well studied, where glucose is oxidized by undergoing 10 enzymatic transformations into 2 molecules of pyruvate. And there is one particular enzymatic reaction that is known as Aldolase reaction, where glucose 6 is first modified to glucose 6-phosphate, then to isomerized to fructose 6-phosphate, again phosphorylated to fructose 1,6-bisphosphate. And the 4th enzymatic reaction step, which is mediated by aldolase, where fructose 1,6-bisphosphate, it is made into, it is a 6-carbon atom molecule, of course, having 1 phosphate group at the top, first carbon atom, and another carbon atom, another phosphate group at the 6th carbon atom down. This fructose 1,6-bisphosphate, it is broken down into 2 equal halves, 3 carbon atoms each way. The first 3 carbon atoms, first, second, and third, they are resolved into dihydroxyacetone phosphate and
glyceraldehyde 3-phosphate.
4th, 5th, and 6th. Very good. That are resolved into glyceraldehyde 3-phosphate. Now the point is that how to know about first, second, and third, they are going to be resolved into dihydroxyacetone phosphate. 4th, 5th, and 6th, they are resolved into glyceraldehyde 3-phosphate. So this has been made possible to know about by introducing C14 carbon atom as a substitute for C12 carbon atom. First carbon atom of glucose, which is CHO, aldehyde functional group, where the carbon atom of that particular one, that is C12 carbon atom, natural isotope, if it is replaced or substituted with C14, then that glucose is fed to animals or even bacteria for that matter. Then if you can track from which carbon atom the beta radiation is being emitted due to the presence of C14, we can make out it is from the first carbon atom because we have labeled only first carbon atom. And at the end, and in the sense, 4th reaction step of aldolase, where this first carbon atom is present, if you track, you can find its presence as the first carbon atom of dihydroxyacetone phosphate, from which the beta radiation is emitted. Like this, with the usage of radioactive isotopes in the biological research, they could be able to label these biomolecules or biochemicals with radioactive isotopes. Like if you want to label DNA, you can go for either C14 or H3 or even phosphorus 32. Or if you want to label a protein molecule, you can go for S35 exclusive, where cysteine amino acid residue or methionine are present. So like this, radioactive techniques or radioactive labeling techniques are tracer techniques. That when these techniques were begun to use, then people could be able to chase or track the biosynthetic pathways and degradation pathways of these metabolites. That includes primary metabolites and as well as secondary metabolites. That's how people could be able to understand secondary metabolism for the past 65 years. And he's the scientist, Sandner, who could be able to isolate morphine, the drug which was isolated from Papaver somniferum or poppy plant. Right. So there are 4 lakh known species. It is said that as far as plants are concerned in plant kingdom, and these are the plants which can produce more than 1 lakh in number. It is more than that. Low molecular weight having secondary metabolites. They are low not only as far as their molecular weight is concerned, because of their smaller structures, of course, but also low as far as the volume or quantity of these molecules that are produced in the plants under natural conditions in the wild, right? So of the 4 lakh higher plants, it is said that just above 10% of these plants, they have been characterized chemically for the phytochemicals they produce. These secondary metabolites, they are known as phytochemicals or plant secondary metabolites or specialized chemicals. Just I have seen earlier, I have made a mention, primary metabolites, they contribute for the energy metabolism of the cell or whole organism, whereas the secondary metabolites, they do not contribute for the cellular energy metabolism or organisms energy metabolism. But why they are produced? In the sense, as far as the secondary metabolites are concerned, they can be considered as markers for the living creature. Say certain marine organisms, they produce a particular compound, secondary metabolite, exclusively. So we can categorize or characterize that particular organism by virtue of the presence of this particular secondary metabolite class. Same is the case with plants also. Suppose if you are given a jasmine flower or a lemon fruit, even if our eyes are tied with a piece of cloth, by sensing the fragrance, of course, flower, we can make it out whether it is a lemon fruit or even orange fruit for that matter, or jasmine flower. So how it is possible in the sense, there are exclusive kind of secondary metabolites that are produced by these. For example, lemon fruit, it is limonene, and jasmine flower, it is jasmonic acid. These are the molecules which are responsible for the fragrance this flower or fruit they emit. That means in nature, in the wild, these plants, to show off their presence in the nature, they do synthesize these specialized chemicals. That is one thing. Another thing is that to protect themselves from the vulnerabilities of the surrounding environment or atmosphere, these plants, they are able to produce this secondary metabolites. Right. So the flower or fragrance which we sense, that is because of the presence of monoterpenoid molecules, which are volatile in nature, which can diffuse into the air. Right. So from these plant secondary metabolites, 1/4 of the pharmaceuticals derived that are there in the market, 1/4, even more than that nowadays, these pharmaceuticals, they are derived from the plants. The corporate giants of pharmaceutical industry like Cipla and all, if you see, the painkiller, the balm or cream, whatever it is, that contains capsaicin. Capsaicin is one of the alkaloids produced by chilies, red chilies. Okay, so even Ranbaxy, Ranchem, they have extracted oil from the garlic, and which is made into capsule, and it is being sold as garlic oil, right? So like this, many products are there in the market nowadays, whether it is allopathy or homeopathy, Ayurveda, Siddha, Unani, whatever it may be. Everywhere you can have the presence of this plant secondary metabolites, of course, which are natural products. Right. 11% of the 252 basic and essential drugs, as far as World Health Organization survey is concerned, they are exclusively derived from the flowering plants. And the market is more than $30 billion per annum for secondary metabolites. Right. So we have the secondary metabolites produced by different organisms. This is the slide which depicts about marine organism contribution for anti-cancer drugs, where you can have the DNA topoisomerase inhibitors and DNA polymerase inhibitors, apoptosis promoters or apoptosis inducers, antioxidants, UV sunscreens, many are there. Right. So as far as secondary metabolites are concerned, I have already told you that their exact role is plant defense, and to show the existence or presence of these plants in the nature, and to attract pollinators so that their next generation can be there in the existence, and to communicate with other plants, either positively or negatively. Positively in the sense, sometimes what happens is a phytochemical or secondary metabolite, which is released by a particular plant, may influence the other plant to grow properly. So that is nothing but a hand-in-hand friendly approach. Symbiotic association, you can say, in case of microorganisms and plants, rhizobial bacterial species and legume plants, or one plant can influence other plant to grow properly or healthy. Or sometimes what happens is, because of the phytochemicals or secondary metabolites released by one particular plant, the growth of other plants in the surrounding vicinity that are discouraged. That is negative influence. That's what we call as allelopathic interaction of the plants through these secondary metabolites. And for human benefit, we do use these secondary metabolites or the plant tissues which do have these secondary metabolites. It may be leaf or bark or flower petals or fruit peel, whatever it may be. We do use this as source as flowers, fragrances, dyes, pesticides, and as well as pharmaceuticals. Right. So one of the examples, if you look at, this is periwinkle. There is another slide, we can see that one. This is Vinca rosea or periwinkle, which we can commonly see in our surrounding environment. So this is the plant which is generally neglected. Of course, the flowers which may not be used for regular purpose, but still this is the plant which is a source of life-saving drugs like vinblastine and vincristine. These are the two drugs, two alkaloids, which are used for the treatment of cancer. And there is another tree that is able to produce this paclitaxel or taxol, Taxus species. So that is the tree. We can have the slide later on. So this, from bark of which it contains this paclitaxel or taxol, which is used as anti-cancer drug. If any compound or any molecule is to be used as human ailment treatments for the purpose, that must be approved by Food and Drug Administration Agency, that is FDA of government of US or US. So that FDA approved drugs, these are vincristine, vinblastine, as well as taxol or paclitaxel. And analgesic drug, that is morphine, which was isolated way back in 1806, the first drug from opium poppy. So this is used as analgesic. And these plant secondary metabolites, they serve as sources of molecule, the sense basic structure of this molecule, which can be slightly modified. So they serve as modal molecule or basic molecule, which can be modified synthetically in the laboratory by synthetic organic chemistry, and the drugs can be synthesized like this. So they can serve as basis. These are some of the plant species which can produce different kinds of molecules, which we are going to discuss. Right. So this is don't be scared. This is the metabolic. These are the metabolic pathways for the biosynthesis of or degradation of these vital biomolecules, biochemicals, like smaller molecules like amino acid residues, nucleotide bases, and as well as fatty acids and monosaccharides, or their catabolic products like acetyl-CoA, pyruvate, shikimic acid, like this, right? So this is the metabolic pathway. This is primary carbon metabolism, where you can have from protein molecules amino acids are produced. These amino acid residues, they are oxidized to give different molecules that are known as pyruvates, alpha ketoglutarate, or oxaloacetate, or so, which are known as precursor molecules. Amino acids are building blocks or small molecules. Similarly, the fatty acids from triacyl glycerols or lipids, which are oxidized to give acetyl-CoA, and from glucose is from starch, of course, you can get the pyruvate. This is primary metabolism. Generally we say primary carbon metabolism. But if you look at secondary carbon metabolism, primary carbon metabolism, it contributes for the biosynthesis of secondary metabolites or secondary metabolism. You can have different pathways here. That is malonic acid pathway, and mevalonic acid pathway, methyl erythritol phosphate pathway. So these are the pathways. Say for example, malonic acid pathway, from which you can expect the biosynthesis of phenolic compounds. Similarly, aromatic amino acids like tyrosine and phenylalanine, they also contribute for the biosynthesis of phenolic compounds. Mevalonic acid pathway, in primary metabolism, this mevalonic acid pathway, it contributes for the biosynthesis of sterols. Say in animals, it is cholesterol. In fungi, it is ergosterol. And in case of plants, there are more than one sterols are there, like cycloartinol, lanosterol, stigmosterol, cytosterol, like this. Put together, these sterol molecules are known as phytosterols. And MEP pathway also contributes for the synthesis of these sterols. But coming to this, that are cholesterol or these sterols, they are primary metabolites. If you look at the secondary metabolite contribution as far as these particular pathways are concerned, they are responsible for the synthesis of terpenes. One of the terpene class, it is monoterpenes. Just now I have made a mention, it is limonene and jasmine. So these are the molecules which are produced as volatile compounds by present in the lemon and as well as jasmine flowers. Right. So this is the pictorial depiction which shows the contribution of primary metabolism for different classes of or different kinds of secondary metabolites. Right. These secondary metabolites are broadly classified into alkaloids, phenolics, and as well as terpenoids. I told there are many subclasses are there. As far as alkaloids are concerned, these alkaloids are produced from amino acid residues. And the term it is alkali means it is a basic alkali kind of compound and which are heterocyclic in nature. The characteristic feature of these alkaloids is they do have this nitrogen atom presence. So these are basic heterocyclic nitrogen containing compounds that are produced by many plant species and as well as microorganisms, certain fungi and bacterial species. Their classification, if you look at broadly, they are classified as protoalkaloids, true alkaloids, and as well as pseudoalkaloids. And these alkaloids, most of these, they are used as analgesic compounds and as well as FDA approved anti-cancer compounds. Some examples, if you look at Berberis vulgaris, its bark, it contains berberin. This is the alkaloid which has very wide applications. And Papaver somniferum, that is poppy, right? Afghanistan, this is grown as a crop and where alkaloids are extracted and they are given to other countries either in legal route or illegal route also. And with the economy of this Afghanistan, it is dependent on the products of this Papaver somniferum. Morphine, it is one of the analgesic drug is being used as, which is from Papaver somniferum. Like this, many plants are there. And tobacco, which is known for the presence of nicotine, that is an alkaloid. This is the Nicotiana tabacum, where nicotine is. And you can also have coffee, where most of us bed coffee we do enjoy. That is the coffee which contains this caffeine, right? Which is which gives a refreshing kind of feeling as far as morning coffee is concerned. Even between the day, even if you have it in the evening also, you can have this same kind of feeling you can experience. And this is Piper nigrum. What we call is since it produces piperine, right? So these alkaloids, they do have their biochemical influences on certain enzymes and as well as production or biosynthesis of certain molecules which are associated with disease conditions. For example, if you take diabetes mellitus, it is type 2 diabetes I'm talking about, where it is a lifestyle disease. Because of sedentary lifestyle, we can have this diabetes, type 2 diabetes. And there are some alkaloids that are used, some plant products as drugs to inhibit this alpha amylase and alpha glucosidase. Because alpha amylase enzyme is required for the breakdown of starch into maltose, and alpha glucosidase is required for the breakdown of this maltose into glucose, and glucose is assimilated into the bloodstream, and blood glucose levels are elevated. As the elevated blood glucose levels, which is known as hyperglycemia, if it persists for longer durations, then it is type 2 diabetes mellitus, which is because of course, there is a defect in insulin secretion, or maybe function of the insulin, it is get impaired. However, as one of the management strategies for this type 2 diabetes, what they do is they do supplement, or they do provide as drugs the inhibitors of this alpha amylase and alpha glucosidase, so that the starch degradation into glucose that can be delayed, and blood glucose levels at a time may not be raised up. Slowly, the blood glucose levels may be increased. So that is one of the ways the diabetes mellitus can be managed. And there are some alkaloids which can stimulate the pancreatic beta cells, and even they do help for the regeneration of this pancreatic beta cells to secrete insulin, so that are known as insulin secretagogues, which can influence the beta cells of pancreas, and they improve diabetic induced oxidative stress. I've used a term that is sedentary lifestyle. This sedentary lifestyle contributes for the increase in production of reactive oxygen species. Oxygen is very vital element, very much required for the survivability of aerobic organisms. Of course, most of the organisms are aerobic, very few bacteria that are anaerobic. So all living creatures, they do require oxygen. But even under normal conditions, we claim ourselves like I'm perfectly healthy, right? Even under normal conditions, in a very healthy person or healthy living cells, 5% of oxygen, it is converted into reactive oxygen species, but without contributing for any deleterious effects. Why it is in the sense, would you have some antioxidant enzymes that are, say, for example, superoxide dismutase, catalase, like this, these enzymes, glutathione peroxidase, glutathione reductase, these are all known as antioxidant enzymes. These enzymes, they are very active in the normal persons, healthy condition, and these enzymes, they act on these reactive oxygen species, and they make these reactive oxygen species not to become dangerous. But if it is a distress means thinking negative or experiencing some kind of negative feelings, negative thoughts or so, that leads to distress, and it is purely lifestyle borne. And this distress contributes for the production or generation of reactive oxygen species above 5%, where the antioxidant enzymes or antioxidant molecules may not be able to cope the situation, and that lead to deterioration of the health. That's what oxidative stress we call it as. So that is one of the reasons for this lifestyle borne diseases. It may be obesity, hypertension, diabetes mellitus, or so. For all these, some of the alkaloids can be used as management strategies or drug candidates. I told you that the wonderful plant periwinkle, these are the alkaloids, indole alkaloids that are known as. Indole functional group is present in L-tryptophan, the amanase residue, which is a precursor for this alkaloids to be synthesized in this periwinkle, vincristine, vinblastine also. Anti-cancer properties of alkaloids, I have already made a mention about, where you can have anti-angiogenesis, blood vessel biosynthesis, and blood vessel connectivity to the tumor that can be suppressed by some of the alkaloids. And apoptosis promotion, where programmed cell death program that can be induced, and cell cycle can be arrested. You can see some of the molecules which are cell cycle inhibitors, are which can arrest the cell cycle by inhibiting the polymerization of tubulin protein molecules for the formation of microtubules, or the microtubules which are required for the formation, pulling off of sister chromatids from metaphase. Like this, many molecules are there, alkaloids, which can be anti-cancer in nature, that are FDA approved. Right. As far as the studies are concerned, how a particular compound can be evaluated for its anti-cancer property, in the sense that is grafting. It is generally performed in mice, where cancer cells are taken and that are grafted to the mouse or experimental animal, of course, commonly. And then cancer is induced in these particular animals. And the compounds are extracts of plant origin that can be given to this particular grafted animals, laboratory animals, and they are monitored for the growth of the cancerous tissue or tumor. And if there is suppression of the tumor, then the compound or phytochemical or extract, plant extract, it is considered to have this anti-tumor property. Further, they go for the deeper evaluation so as to understand where or how this particular compound or these particular extracts they can suppress the cancer by monitoring some of the marker enzymes and molecules, and as well as certain metabolic pathways as far as these phytocompounds or plant extract influence is concerned. Once the evaluation is done, preclinical trials and all those things, then that can be tested on higher animals, and finally human trials can be initiated, clinical trials. That's how, for not only for cancer, any kind of human ailment, these are the trials which are done by the experts. Right. So these are the molecules and the plants that produce these alkaloid compounds. For example, periwinkle produces vinco alkaloids, and happy tree or Campothica acuminata, which produces camptothecin. And we can also have this specific yellow Taxus bravofolia, which produces taxane derivatives like paclitaxel, docetaxel, carbozitaxel, like this. And Podophyllum peltatum that produces podophyllatoxin derivatives, etoposide, teniposide, and opium poppy, Papaver somniferum, that produces isophenol alkaloids like noscapine also. And Cannabis Sativa, this is another plant which contributes for the economy of Afghanistan. Cannabis Sativa that produces cannabinoids. So these are all the molecules, these molecules which have been approved by FDA to be administered to the human being for the treatment of cancers. Not only for cancer, even neurodegenerative diseases also, these alkaloids are useful. Some of the alkaloids that have been evaluated for this particular purpose. So the second class of these secondary metabolites are natural products. If you look at, these are polyphenols. Benzene, the cyclic structure of a 6-carbon atom molecule, if it is hydroxylated, benzene as such we call it as phenyl. And if it is hydroxylated at the 4th carbon atom position, we say it as para position, right? Chemistry in chemical language, of course. Then it is called as phenol.
Phenol.
So polyphenol means which are having these benzene-like cyclic structures that do have hydroxy functional groups. And these polyphenols, they are phytonutrients. They are present in the plant products, leaves, fruits, even vegetables also, of course. From even seeds also, they do contain these polyphenols. These are generally considered as micronutrients. And certain fruits, if you look at, say for example, apple, it is color, right? And similarly, you can also have pomegranate. If you open that fruit, you can have the seeds with color. Like this, grapes are also colored. And people say that experts, your food must be colorful. The colorful in the sense, it doesn't mean that we have to spray the color with. We can have the food with this kind of colored fruits and vegetables. Tomato, for example, the color it is because of lycopene, the red color. Of course, carotene, beta carotene is also present. Like this, we can have these polyphenols which contribute for this colorful appearance of the fruits and vegetables. And these are the ones which are this colored nature. It is because of the presence of anthocyanin pigments. We know about chlorophyll, beta carotene, xanthophylls, beta cyanins, and phycoerythrins and all. These are all one class of pigments. We have anthocyanins, which belong to flavonoid class of molecules, which contribute for the pigmentation of these particular fruits and flowers. Right. So these are some of the examples of polyphenols and their subclasses. If you look at, these can be phenolic acids like caffeic acid, ferulic acid, like this gallic acid and all. Phenolic acids are there. And there are flavonoids like anthocyanins, flavonols also. Examples are quercetin, the commonly present phenolic compound, flavonoid compound. It is diargine, epigenin, naringenin, catechin, and all. And there are non-flavonoid class of molecules like stilbenes and lignans. These lignans are also known as phytoestrogens. They do have the human or animal estrogen-like structure, and of course, they do have such kind of function also. And this is stilbene class where resveratrol. This is the molecule which is present in grapes and as well as groundnut seeds. Groundnut seeds also they contain this resveratrol, which can promote heart health. So these are some of the examples where we can have the phenolics or phenolic rich compounds, that are present in these fruits, leaves, and as well as vegetables. And characteristic feature of these phenolics is they do not contain any nitrogen atom, but they do have this benzene with hydroxy functional groups, which are fused to each other, the cyclic structures, for the formation of 15 number carbon atoms with or many numbers. These are flower petals, pelargonidine that is responsible for red color pigmentation of flower petals, cyanidin, delphinidin, like this. And resveratrol, which is present in grapes, the wine which is made out of with grape, that is good for health, people say, experts say, because of the presence of this resveratrol. And there is cambritastatin also. Ice creams, generally the college students, they love ice creams. Of course, some people, they are fascinated for this vanilla flavor. That is vanilla, which is because of the presence of this vanillin compound. Like this ginger, which contains gingerol. Nowadays, the COVID pandemic, after this, for corona, the decoction which is made out of with ginger and all, that can be used for management, cure of corona, also corona infection. So it is maybe because of the presence of this phenolic compound like gingerol in the ginger. Like this cinnamon bark, it contains cinnamaldehyde, and coffee beans, they do contain chlorogenic acid. This is phenolic acid, and coffee beans, the earlier instance we have seen as far as alkaloids are concerned, they do contain caffeine, the alkaloid. And green tea, it has become very popular nowadays as health promoting drink. So green tea leaves, they do contain this epicatechin and as well as epigallocatechin. These are the ones which are having health promoting benefits. Right. The polyphenols in their isolated form as pure compounds or the extracts of the plant tissues, they do have health promoting or health benefits, health promoting effects. Like they can be used as anti-inflammatory and anti-infective. That means antimicrobial, anti-cancer, neuroprotective, anti-aging, and as well as anti-asthmatic, cardioprotective, anti-diabetic, and cerebrovascular protection. So this is anti-aging creams. If you see many creams that are there in the market, so they do have these polyphenolic compounds, particularly flavonoids. Right. So these polyphenolic compounds, they do function as antioxidant molecules by scavenging hydrogen peroxide, hydroxy radical, superoxide radicals, singlet oxygens, peroxide radicals. All these radicals which are produced from molecular oxygen, the vital element which is required for the survivability of aerobic organisms. But under distress conditions, this oxygen, it turns to become toxic by becoming radicals because of the partial saturation of this, partial reduction of this oxygen. So these free radicals like hydroxy radical, singlet oxygen, superoxide radical, hydrogen peroxide, they are scavenged by antioxidant molecules like phenolic compounds or their subclass like flavonoids. That's how these phenolics or polyphenols, they can protect the health of individuals. And these polyphenolic compounds, they are used as used in ophthalmic suspensions or drugs, and they can be used as immunomodulatory compounds, anti-carcinogenic, neuroprotective, cardiovascular protective, and as well as diabetes. And recently, during this second wave of COVID epidemic, corona epidemic, one formulation has become very popular in Andhra, of course from Nellore district. So he uses many plant products, right from flowers of Calotropis gigantea, even the fruits and all those things. With honey, it is boiled. So that is the health promoting effects of that particular formulation become maybe because of the presence of this alkaloids and as well as phenolics and other class of molecules, terpenoids. Right. So oxidative stress, I told, because of sedentary lifestyle, reactive oxygen species production becomes beyond the body's ability to cope. So that this oxidative stress is responsible for obesity and as well as diabetes, hypertension, and aging, and as well as dyslipidemia. And smoking adds up to this particular oxidative stress, and that leads to endothelial dysfunction. So these can be managed, or even sometimes can be cured by the administration of phenolic compounds or phenolic compound rich products. Right. The third class are terpenoid molecules. These terpenoids, they are hemiterpenoids, monoterpenoids or monoterpenes, sesquiterpenes, sesterpenes, diterpenes, triterpenes, and polyenes or polyterpenes. They are classified into depending upon the number of carbon atoms they do have. For example, hemiterpenes, if you look at, these are 5 carbon atom molecules. They are known as isoprenes or isoprenoids. Examples are dimethylallyl pyrophosphate, isopentyl pyrophosphate, which you come across while learning about cholesterol biosynthesis. And 10 carbon atom molecules, monoterpenoids. The example already I have given, limonene, that is one of the monoterpenoids. And you can also have diterpenoids, triterpenoids like this. Cholesterol is a triterpenoid molecule. So these are examples for monoterpenoids like myrcene, linalool, pinene, limonene, like this. And these are volatile compounds, monoterpenes. Whatever the deodorants or scents we use, they're all rich in these monoterpenes. Because these monoterpenes are volatile, they can easily diffuse into the air. That's how they show up their presence in the surrounding environment with characteristic fragrance or flavor. Okay. So this, characteristic fragrance. So these are some of the examples of monoterpenes. And similarly, you can also have some diterpenoid molecules and as well as triterpenoid molecules. And triterpenoid molecules, they are known as saponins. These saponine molecules, they are triterpenoid molecules. And these saponins, once you put into the water, they give foam or froth, saponin molecules. And this froth is because of the presence of these saponins, which do have the soap-like properties. And these saponins can be triterpenoid saponins or steroidal saponins, which do have structural similarity for cholesterol. And these molecules, these saponin molecules, they are glycosylated, and once they are given, they are added to the RBC, for example, that is the conformation test, which generally it is done for the confirmation of presence of saponins in the plant extracts, where saponins, they induce pores in the RBC, red blood corpuscles, and through that pores, the hemoglobin contents or contents in the RBC, they leaked out, as a result of which you can see the solution, that is saline, in which we take the RBC, that turns to become red. That is hemolysis, we call it as. That is hemolysis test is one of the tests which is used for the confirmation of presence of saponins in the extracts. Right. Okay. So how to overcome the barrier? The barrier means that is nothing but, for example, if you look at this particular thing, this is story of Taxol. The Taxol, which was identified in 1967 by National Cancer Institute, US, and this Taxol or paclitaxel, now it is called as, it is produced or it is accumulated in the bark of the Pacific yew tree, that is known as Taxus brevifolia. Remember, see this is Pacific yew tree, and it was used by the American Indian for treatment of inflammation. Inflammation means pain like condition. Later, it was developed as anti-cancer agent by a corporate company that is known as Bristol Myers Squibb Company. And this is the paclitaxel, which is present in bark of this specific yew tree. And this is how the bark, it is peeled off from this particular tree stem or trunk, of course, stem. Then that can be used for the extraction of this paclitaxel. So in 1955, 35,000 trees have been screened, plants have been screened for the presence of anti-cancer drugs. 1967, Taxol was identified in the specific yew tree bark. In 1969, 10 grams of this pure compound, Taxol, was isolated from 1,200 kgs of bark. 1,200 kgs of bark cannot be expected from single tree. So many trees, the bark is to be peeled off to get 10 grams of this pure compound. And this is the 10 grams of pure compound which is required for the treatment of one particular patient, one cancer patient. So just imagine how many number of trees are to be peeled off as far as their bark is concerned. Right? That to cancer is leukemia. In 1979, the mechanism of action of this paclitaxel or Taxol, which was called then, and it has been confirmed as, which can inhibit the cell division. In 1984, phase 1 clinical trials were done, and 1988 phase 2 clinical trials were done, and then 30 in human beings, the trials were conducted. 30% patients could able to overcome this particular cancer disease due to the because of the administration of paclitaxel, and even ovarian cancer also. So later what happened, it has become a problem for the supply of this particular compound, because 10 grams is required for the treatment of one individual, one cancer patient, which needs to have the requirement of 1,200 kgs of bark. So then they have developed the technology for the production of this Taxol by endophytic fungi or alternative sources. That's how they could able to overcome the problem of supply of this particular Taxol molecule. Right? What are the ways, without destroying or without causing any destructive harvesting of plants from the wild or nature, whether do we have any alternative ways and means for the production of these vital secondary metabolites or natural products in the laboratory or at industry level? If you look at plant cell cultures are one of the alternatives, and you can also have the plant genes that are cloned in the yeast cell factories, so that yeast can be made to produce this plant compound. So we need not to go for the plant always to destroy the plant, bring it to the laboratory, plug the plant or plant organs, bring it to the laboratory and go for the extraction of the compounds. There is a process known as fermentation, where fermenters are available, and these yeast cultures or plant cell cultures can be grown in the fermenters, and we can have the desired product of your choice that can be produced. Right. So we can also design the microorganisms to suit for the production of your desired compound by different ways. And bioinformatics, this is one of the branches of science, modern science, which can help for this particular purpose. And we can also have the biochemical pathways that are elucidated, so that genetic engineering approaches, where the lower organisms like bacteria or fungi like yeast or so, in which you can produce your desired compounds by having different ways and means. One such kind is pathway engineering, and of course recombinant DNA technology you can apply. So these are genetic engineering approaches, where lower organisms like E. coli, the bacterium, and another one gram positive, this is E. coli is gram negative, and gram positive bacterium is Bacillus subtilis, Schizosaccharomyces pombe, yeast, and Saccharomyces cerevisiae. These are the lower organisms, unicellular organisms, which can be used for the production of molecules of our choice, as far as these natural products or secondary metabolites are concerned. And these are the organisms which are generally used for the production of isoprenoids and polyketides. So Baker's yeast, that's what Saccharomyces cerevisiae, which can be used for the production of some of the useful molecules that includes saponins. And these are known as Designer yeast for biocatalytic applications that can be used, and metabolic engineering, that is one of the routes for the production of the molecules. There are many synthetic pathways. Yeah. So this is what I told saponins. These are the molecules where these are the phytosterols, and common precursor for this phytosterol biosynthesis or saponin biosynthesis is 2,3-oxidose, which is produced by Metabolic pathway from acetyl-CoA. Acetyl-CoA is expected from glucose oxidation via pyruvate, or as directly by the oxidation of fatty acids, even by the oxidation of pyruvate from, say, amino acid like L-alanine. And this classification of saponins, I have already told you that these can be triterpenoid saponins and steroidal saponins. This is steroidal saponin, which is similar to that of cholesterol as far as structure is concerned, and this is triterpenoid saponin molecules. There are many such kind of molecules that have been isolated from plants, either from leaves or flowers or fruits. And this is oats. Oats are very, very good agents for the management of diabetes, right? So in the roots of oat plant, you can have one particular kind of saponin, that is triterpenoid saponin, while in the leaves of the same oat plant, you can have the presence of steroidal saponin. So it depends. So these are some of the examples of steroids that are, these saponin molecules that are present in different plants. So this is the molecule gymnamic acid. Please remember this. Within few minutes, we can have something interesting as far as this gymnamic acid is concerned. So what are the biological activities of these saponins? If you look at, they do induce pores in the membrane. They affect the cell membrane permeability. So microorganisms, if it is a pathogen, the pathogen membrane can be induced with pore, so that membrane permeability is altered and pathogen can be killed. And that is a test which we do by using RBC suspension for the confirmation of saponin presence in the plant extract. They do have hypoglycemic activity, so that they are anti-hyperglycemic or anti-diabetic. They interfere with cholesterol metabolism, so that the hypertension or so that can be managed. They do have the ability to induce animal reproduction. They are antiviral, anti-inflammatory, hypolipidemic. Lipid profiles can be managed properly. They do help for protein digestion, even for the preparation of vaccine. One of the saponins that is known as quilazasapine, that is used as adjuvant for the preparation of vaccines. They are antimicrobial, antibacterial, antifungal, and as well as antiviral, as far as these saponins are concerned. So this is the ginsenoside that is present in Korean plant, ginseng. And we do have a plant that is known as Centella asiatica, and as well as another plant, Bacopa moneri, Saraswati chittu, that is known as. So that is the one which produces bacosides that do have memory enhancing ability. Earlier, now you may be knowing about Nitin Kapoor, produces television serials. Nitin Kapoor's father, Jitendra, was one of the model for the promotion of CSIR, Council of Scientific and Industrial Research Institute. They have developed a formulation that is known as Memory Plus. It was available in the form of capsules and powder, right? So that is from Bacopa moneri, Brahmi plant. This is another interesting plant, Glycolysis glabra or licori, whose root, it produces some interesting saponin molecules which taste sweet. And not only the plants that produce these saponin molecules, this is the picture of sea cucumber. Cucurbits, as far as plant per se is concerned, cucurbitaceae family members, to which our cucumber, then bottle gourd, ridge gourd, bitter gourd, all these that belong to, they do produce rich amounts of saponins. They do have the rich amounts of saponins. And parallelly, as far as animal per se is concerned, sea cucumber, which is available in the sea, Holothurias scabra, that also produces the sapnin molecules. And this is one of the favorite dish for Chinese. And these sea cucumbers, they are hunt from the marine waters, and they are smuggled to China from India. That's why the hunting of the sea cucumbers and catching, that has been banned in India as far as the sea cucumbers and their sapnin content is concerned. Right. This is the plant which I told, Gymnema sylvestre, which produces this gymnemic acid. Gymnemic acid, it is not single compound. It is a group of sapnin molecules where this R3, R1, R2 you can see. So these are the functional groups. Hydrogen atoms of functional group or sugar residue that can be that can be the substitutes. So these Gymnema sylvestre sapnin molecules, they do have anti-diabetic and as well as anti-obesity properties. And there is a tea powder that is available, the dried leaves of this Gymnema that are sold as Gymnema tea powder. A tea can be made out of this Gymnema powder, can be used for the management of diabetes and hyperlipidemia and as well as obesity. And fenugreek, methi, the leaves and as well as seeds, they do have these steroidal saponins like diastenin, gitogenin, and smilagenin also. And this, as we know that fenugreek seeds, methi seeds, they do have anti-diabetic property and as well as hypolipidemic property. Similarly, garlic, I told you that Ranbaxy company, they extract the oil of this garlic and that is sold in the medical shops, right? So as a medicine it is used. And the saponins that are present in this garlic, that are the molecules which are responsible for the medicinal property or medicinal feature of this health promoting benefits, health promoting ability of this garlic. Right. What we have been doing while introducing me, they said about published papers, produced PhDs, and also brought the research grants. So this is one of the plants which is known as Mucuna species, Mucuna prurata and Mucuna prurines, and that belongs to Fabaceae family. And the seeds of this particular plant, they are rich in L-dopa. L-dopa, that is dopa, which is a precursor for neurotransmitter dopamine. There is a lifestyle-borne disease, aged people, they do have age-related complication. The neck movement and hand movements, if you look at, that are unstoppable. Even if we try to hold, it is not possible to stop the movement of this neck and hands. That is because of the deficiency of dopamine. For that people or for that patients, the disease, it is Parkinson's disease. This dopa is given as a drug, where in the brain cells, this dopa is converted into dopamine, so that the dopamine restoration can be a possibility. So Mucuna prurines and Mucuna prurata, the two plant species, they are rich in L-dopa. The seed powder that can be used as a drug or source of dopa as a drug for the Parkinson's patients. And we do produce this callus, and from the callus we do prepare, say, suspension cultures, and we do induce this callus suspension cultures to produce the phytochemical which is produced by the plant in wild. So that destructive harvesting of the plant from the wild environment or from nature can be avoided. So this is genetic transformation of this Mucuna prurines with Agrobacterium tumefaciens, where transformed callus culture, it appears blue in color. That is the confirmation that transformation has been successful. And we do work with some other plants. This is Gymnema sylvestre, which is cultured in the lab, and we do overproduce the compound. And this is Plumbago gelanica, plumbagin, that is polycated molecule, which is anti-cancer compound. And we do go for the comparison and evaluation of molecules that can specifically inhibit primary metabolism like sterol metabolism, sterol biosynthesis, so that the common precursor I told, 2,3-oxidosqualene, can be diverted for the synthesis of sapnin molecules. This is one of the in silico study using bioinformatics tools we could able to confirm a particular compound, ketoconazole soaps and creams that are available for fungal infection treatment. That ketoconazole can inhibit phytosterol biosynthesis, cycloartenol biosynthesis, so that 2,3-oxidosqualene, it can be diverted for the synthesis of saponins. Right. So this is another plant which is commonly seen, tumme, right? Leucas aspera, which is very good source for some of the important saponin molecules that we overproduced in the laboratory by growing this plant in the laboratory vessel. And this is Nedia glauca, another plant which we use for the extraction of compounds. And this is how the suspension cultures of callus that are elicited for the production of desired secondary metabolites using ester like methyl jasmonate and salicylic acid. This is another plant, Anisomelis indica, a common weed. You can see roadsides, even in Kurnool that is available, I believe. It is available, of course, I have seen. So this is the plant which looks like mint. It is a mint family member to which your mint like basil, tulsi, and as well as mint that is pudina they belong to. If you just pluck the leaf and just mince it and smell it, you can experience a very good fragrance. So that is, it contains essential oil and as well as monoterpene molecules. So that are the molecules which have been characterized by different techniques like thin layer chromatography, high performance liquid chromatography, and as well as, of course, for volatiles gas chromatography it is. And this plant, Anisomelis indica, which is a weed, common weed, which is available commonly in the nature, even in urban spaces also. It is a source of important flavonoid molecules which are having health promoting benefits like camphorol, quercetin, epicatechin, and epigenin, and luteolin, all these molecules which we have extracted, and that has been tested. This flavonoid extract has been tested for the protective effects on erythrocytes, where erythrocytes were treated with hydrogen peroxide. The membrane, it is ruptured like this. So erythrocytes are lysed after some time, after 60 minutes of exposure to hydrogen peroxide. Same erythrocytes, if they are treated with this flavonoid extract of Anisomelis indica, then if you add H2O2, hydrogen peroxide, erythrocytes are protected. So this is how the cells that can be protected by this flavonoid extracts of Anisomelis indica. Similarly, there are pathogens which infest food grains. Onion, if you see some of the onions that appear black spots that are present, that is because of the presence of some fungal infection, that is Aspergillus species. They produce the toxin aflatoxin. These aflatoxins are liver cancer inducing compounds. Nowadays you can hear, I was seen in the media, print media and as well as visual media, black fungus, white fungus, and all those things. So this Aspergillus that comes under this black fungus category, the essential oil of this Anisomelis indica can inhibit the growth of this black fungus Aspergillus species and suppress the production of these aflatoxins. That's what we could able to confirm. And Gymnema sylvestre, this one Nedia glauca, the alkaloids, terpenoids, and as well as phenolics we have extracted, isolated of course, and that have been tested for control of bacterial blight in rice, and as well as against the pathogen, bacterial blight pathogen of pomegranate, which we could succeed, and these results were published. And this is the plant. Just for a moment, please permit me to stop the slide share. Another 2 minutes we can wind up this presentation. Please permit me. Just a minute. I'll be back. Yeah. So he is, of course, it's not so clear. He is alumnus of St. Joseph College, Kurnool. He studied MSc Biochemistry, and presently he has been with me for his PhD, Mr. Rajshekhar Jerubandi. He has been working on this particular plant for the overproduction of gymnamic acid, the saponin molecules of this plant. This is also known as Madhunashini, which is a sweet destroyer, right? And he could able to overproduce the saponin molecules of this plant in yeast culture. This is just one particular slide where you could able to isolate cDNA and constructed the plasmid construct. Then he could able to mobilize into yeast, and yeast culture, when it was grown, you could able to produce the compounds which were characterized by TLC, later on by mass spectrometry and GCMS, of course. And you could able to demonstrate successfully that the enzyme which is responsible for the production of the saponins of Gymnema sylvestre is a multifunctional enzyme which produces more than one saponins. So that's what you could able to carry out the work for his PhD. Shortly, he is going to get his PhD awarded. So with this, I would like to end up my presentation. If any queries are there, I'm happy to respond.
Yes, thank you, Kumar. Thank you very much for wonderful presentation on natural products. My dear participants, if you have any question or doubt, you can unmute yourself and you can talk to Professor Kumar directly. Any questions? Okay, Deborah, madam. If you have no questions, we'll proceed further.
Sir, can I raise a question, sir?
Yeah, please.
Yes, ma'am. Yes.
Yeah. Sir, presently, Coctus igneus, that's commonly called insulin plant.
Pardon, your voice is not clear, please.
Sir, okay. Sir, actually, Coctus igneus, which is commonly called insulin plant in India.
Yeah.
Yeah. Sir, can I have a small information about that, sir?
Yeah, that is the plant which produces, again, saponin molecules, of course. These saponins, like the example I have given, right? These can be, the saponins can be insulin secretagogues. What happens in case of diabetes people? The pancreas may produce low levels of insulin. I'm talking about type 2 diabetes, not the genetic one, type 1, right? Or there is a possibility of the desensitized insulin receptor, tyrosine kinase receptor. The saponins, they can influence pancreatic beta cells
to rejuvenate, where their number may become lesser. So sufficient amount of insulin may not be able to be produced by these pancreatic beta cells, so that they can induce or insist these pancreatic beta cells to rejuvenate and produce the insulin. That's what we call them as insulin secretagogues. Another thing is that the function of this insulin receptor can also be say mimicked, so as to see that whenever the insulin it is secreted, insulin can be able to be received by this insulin receptor. That is another possibility. And one more thing is that I have shown two enzymes, alpha amylase and alpha glucosidase inhibitors. So some of the saponins, they are alpha amylase, alpha glucosidase inhibitors, but the inhibition is reversible. So these are the possibilities where the saponins can have anti-diabetic property or anti-diabetic ability. Same is the case with insulin plant leaf also. If you have you tasted, ma'am, that insulin?
No, sir. Actually, I didn't have, but a
Yeah.
lot of members are giving information about that. Still, I'm just confused.
Yeah, you are right. It is a little sour taste. And as far as Gymnema sylvestre leaves are concerned, it grows like a weed. This also, it is bitter, that leaves. If you chew the leaves, within 15 minutes, if you put sugar into your mouth, you cannot taste sweetness. Whatever may be the quantity of sugar it is, you just experience as if you are chewing some sand. For 15 minutes, it will be like this. So it is sugar destroyer. Same effect can also be seen with Gymnema.
Charging.
Okay, sir. Thank you.
Dear participants, do you have any more questions? Any more queries? Right. Really, I thank from the bottom of my heart for enriching and sharing us knowledge with us, sir. We are also happy to have a glance about your projects. May God bless you in all your endeavors. Now I request Mrs. Siddika Hassani to give her vote of thanks.
Okay, before Hasini madam comes, I just want to share one thing. Sir, Kumar sir.
Please, sir.
Good evening. I am Dr. C.V. Satyanarayana, sir, Vice Principal.
Yeah.
So actually, I'm from the Department of Computer Science. I don't understand all these things, but after seeing some of your slides with the plants that I'm seeing every day in my life,
Yes, sir.
I feel like I'm missing a lot.
Oh, you are
So
not
the medicine
missing,
is
sir.
before me, but I'm unable to use. Now I have to catch hold of Sirana to give me medicine, whichever I require or whatever I require. Because all these leaves which I'm seeing on the PPT presentation, they're almost visible to our eyes in our garden. When I'm going my home on a bike or a car, whatever, a lot of plants are visible to our eyes. But only thing is, we don't know what that plant is, how it has to be used, why it has to be used.
Yeah.
So really, that's great, sir. So though I don't understand the subject, I still remember those formulas, that benzene formula. So all that is, those are all connected to each other. That's what I understand from your figures and all. But still, it was interesting, sir, because every leaf that you were showing us was something known to us.
Yes.
That coffee beans, lavanga, everything. It's all we use in everyday life. That's what. But inlalo, popla pitta.
You are right.
So it looks like that, sir. So it's like a popula petta in our house. So avanni correct vaadte kuda, I think we will be out of a lot of diseases.
Yes.
So that's really good, sir. We'll be in touch with you, sir, through Sirana.
Sure.
Thanks for the presentation. That was really nice, and it was with the same energy last 1.5 hours. That's great. Thank you, sir.
Thank you, sir.
Yeah.
I once again thank you so much. I really thank you, sir, for spending your valuable time with us and sharing your knowledge and enriching us with your knowledge. And we are really very happy to see what all projects you have made, and we are really happy to share some of our time with you, sir. Thank you so much. I also thank the management and all the HODs, principal and vice principal, for encouraging us to go on with the webinar today. And I also congratulate all the participants for being very patient enough and very enthusiastically they have participated. And thank you all for being with us here today and taking time to patiently listen and get enlightened and enriched. So I wish you all a very blessed weekend ahead. Thank you all. Bye.
Thank you very much, ma'am. I thank Dr. Srinivas and the management of St. Joseph College for the opportunity given to me. Thanks to Corona, because it is a blessing in disguise to have all of us meeting each other online.
Yes.
Thank you very much.
Yes, sir.
Thank you
Yes,
very
of course.
Thank you.
Yes.